All right, today we are going to focus in on isosceles triangles and equilateral triangles a little bit more. First, talking about isosceles triangles. So first, let's talk about parts of the isosceles triangle. So yesterday we talked about isosceles means that at least triangle with two sides congruent. And that, in fact, we don't really want to say at least two sides congruent, because if more than two are congruent, then it's equilateral. So we'll just say with two sides congruent is really what we want to hone in here. So the legs of your triangle are the two sides that are congruent. Vertex angles are where the two legs meet. So this is your vertex angle. That's where your two legs are touching. Let's go ahead and label that angle 1. Our congruent sides are AC and BC. And we're talking about triangle ABC if we're being thorough here. Third side of the triangle is the side opposite your vertex angle, which is the side that is not congruent to the other two, so that'd be AB. And then angles created by the legs in the base are what we call base angles. So this is angle 2 and 3, we'll say. And I'm showing that they are congruent by doing two arcs instead of just the one, since they match. So our isosceles triangle theorem, and we're talking about theorems and converses today, but really they go hand in hand. Converses are just the opposites of the theorems. But this is saying if two sides of a triangle are congruent, so like let's say these two are congruent, then the angles opposite those sides are congruent. So then we would say A and B are congruent. Angle A is congruent to angle B. So that's the forwards direction. Mark which parts on also congruent are also congruent based on the picture. Write the congruence. So they give us these two sides, so that also means that angle A is congruent to angle C. And again, they mark these two sides. That means angle B is congruent to angle A. And then here they marked these two sides, so angle C is congruent to angle B. So these base angles have to be the same. Isosceles triangle theorem converse is the opposite. So in this one we're saying if the two base angles are the same, like if A is congruent to B, then the opposite sides are congruent. So we would be saying that AC is congruent to BC. So just the opposite direction is what the converse is. So mark which parts are also congruent based on the picture. Write the congruence. And they wanted us to mark them here, but we filled them in, so I think that's sufficient. So we're going to mark that AC and BC would be congruent. And here we would say again AC and AB. AC and AB. All right, next page. Use the diagram to fill in the blanks. Tell what theorem you use. So remember, forwards direction means they give us the sides. Converse direction means they give us the angles. So here if AE is congruent to DE, then angle A is congruent to angle D. And that would be the forwards direction, so we want the theorem. If EDC, that'd be this angle, is congruent to CED, then we could say DC is congruent to EC. And since they gave us the angles first, it's the converse. Letter C, if AB is congruent to EB, AB and EB, then angle A is congruent to AEB. And we do need to name the second angle with all three letters. Since E could mean any of these three, we're being more specific by saying AEB. Since they gave us the sides first, it is the theorem. If angle EBC, that's this one, is congruent to ECB, that's this one, then we can say EB is congruent to EC. Since they give us the angles first, that is the converse. Find the value of x. So again, we know that these are congruent angles. They mark those for us. So it means these two sides that are opposite our angles are congruent. So we can say 3x equals 18. which would make x 6. Here they're saying these two sides are congruent, so these two angles at the base are congruent as well. They're opposite those legs. So this is 47. So x has to be 180 minus 47 twice. Or however you want to think about that. So 47 times 2 should be 94. 180 minus 94 is 86. All right, moving on. So here they're saying that these two base angles are congruent, which make these two sides congruent. So then we have 5x plus 7 equals 27. And then that would make 5x 20 and x 4. And we can stop because all they wanted us to find was the value of x. All right, here we're saying these two are equal. So I know that I need 2 x's plus 38 equal to 180. So 180 minus 38 is 142. So x is 71. Last page. Equilateral triangles. So if a triangle is equilateral, then it is also equiangular. And they go hand in hand, like I mentioned yesterday. Can't really have one without the other. So equilateral, if they're marked equilateral, that also means all three angles are congruent. An equiangular triangle is also equilateral, so that's just the opposite direction. We would call that the converse. If they give us the angles first, we would call that the converse, the opposite direction. Angles of equilateral triangle, each angle of an equilateral triangle would be 60 degrees since the total has to be 180. Just 180 divided by 3 there. Find the value of the variables, then give the measures of the angles. I think we lost a word there. So here, this is isosceles. We can't assume it's equilateral without the third side being the same, but I do know that these two would be the same. So I would have 7x minus 27 equals 4x plus 21. Would be 3x equals 48, so x is 16. So these two angles, if I plug 16 back in, would be 85 degrees. Here again, these are isosceles triangles, so these two would be the same, so they're both 2x. So I would do 2x plus 92 equals 180. So we'd have 4x equals 88. So x is 22, which would make these two base angles 44 degrees. Okay, here I have an equilateral triangle, which is going to mean that all three of these angles are 60. And then we're saying that this is an isosceles triangle, so these two base angles are the same. But I can find this angle by doing 180 minus 60 since they're a linear pair, which is 120. 180 minus 120 is 60, and then I have to divide that by 2 since these are the same, so that'd be 30 and 30. X equals 60 degrees, y equals 30 degrees. All right, so on this one, let's start with the isosceles triangle over here on the right, which is going to mean that both of these are x. So I can do 180 minus 44 is 136, I think. And then if I divide that by 2, it'll give me 68 for both of these. So x is 68 degrees. And then this is a linear pair, so this piece would have to be 120. And then just like this triangle, that would make these two, if it's isosceles, 30. All right, last two. Here I have isosceles, so this one must also be 50, which would make this one 80 if they add to 180. Then what else can we do? This is an equilateral triangle, so they're all 60. These three are on a line, so they're a linear pair, would make this one 70. And then I know both of these base angles are 70, which would make x 40 if they add to 180. So x is 40, y is 80. But don't feel like you need to do them in order, like from left to right, because I would not be able to find this middle triangle if I didn't fill in the one on the far right first. So just fill in everything you can and then come back to what you're stuck on. Here, this is 69 degrees, so this has to be 69 as well. So let's see, I add those together and subtract 180, that'll be 42 left over. If these are a right angle, 90 minus 42 is 48. These two base angles are also both 48. So let's fill in this piece, 48 times 2, 180 minus 96 is 84. And then you have a couple of options for this piece. You could, remember the one on the outside is equal to the two on the inside added together. You could say these two have to add to 180. Both of those show you the same answer. So let's go ahead and practice our exterior angle theorem, where we're saying this is equal to my two angles on the interior added together that are not adjacent to my exterior angle. So that would give us 96. And then 96 plus 8 would give me 104, which is 8. X is 8. And I know this angle's 96 total if I add those two together. All right, that's it for today. We are working on worksheet 2.